In this video, I will explain you how to get a DC current with constant amplitude in the output of a full wave rectifier. So output, if you are just taking the output of a full wave rectifier, it would looks like this, where the current increases to a maximum value, then decreases, then again increases to a maximum value, then decreases. So if this is being applied to our mobile phone, then that will damage the system because the current will continuously change. Okay, we need this at the output, a DC current. So how to get that? So we will simply connect it with the capacitor. Now listen, this is very important. What will happen when we are connecting a capacitor? So in the first half, this is forward bias, so current will go in this direction. So in forward bias, current will keep on increasing. So what will happen? The capacitor will be now fully charged. See, from here current will increases and become the maximum value. See how the current will go? Current will go like this, and here this will increases. Current will now get two paths. One is through this and other is through this. Now current will choose the capacitor because capacitor has got lowest resistance, right? Why? The resistance of capacitor is equal to 1 by C omega. So frequency of the AC current is higher, so the resistance is less. So current will choose to go through capacitor. Now what will happen in this case? Capacitor would be fully charged, but a small amount of current would be going through this. So initially I could say that the capacitor would be fully charged. Now after this, what will happen? Current is decreasing. So in this direction current is decreasing. Now when the current is decreasing, across the capacitor there is a potential now. What is the potential? That is a potential created due to the fully charged condition of capacitor. Q is equal to CV and V is equal to Q by C. Now the capacitor is fully charged and the value of potential would be Q by C. Now in this circuit current is decreasing, but the capacitor is fully charged. So what will happen? Now capacitor will deliver a current to this circuit. So though the current is decreasing, but as the capacitor is fully charged, what will happen? Capacitor will deliver a current because capacitor has a potential across it due to fully charged condition, and this doesn't allow current to decrease through this load because the capacitor is discharging. See, capacitor from here, that will discharge here. Now will it completely discharge and go here? No, because by that time next cycle would start, and next cycles this portion has reached. Now from at here, let's say capacitor is discharged, but from there current would be the continuation from the output. Now current would continue in this way. So now the capacitor is again charged. See, current would increase. Now current is supposed to decrease, but what will happen? As capacitor is fully charged, capacitor will deliver the current to this load. Now the load, that would be in this way. Now capacitor is getting discharged, but what will happen? By that time the current in the output, that would continue all the way here, and from here the output would be significant, and that would again charge the capacitor. So it's charging of the capacitor and discharging of the capacitor, that makes a DC current in this way. But I could say that it won't be exactly like this, but we are almost able to get a constant current in the output. So this is how we convert an AC current into a DC current. Now this can also be stabilized to a constant current using a Zener diode that I would explain in the next video. But anyway, now we have converted a DC current with change in magnitude into an almost constant DC current. Okay, thank you.